Hello and welcome to another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 9, Lesson 5, Solving Equations with Fractional Exponents. All right, well this is a first for you, kind of, and we'll discuss why it's just kind of a first for you. But it's very rare that you've solved any kind of an equation where a variable has been raised to a fractional exponent. So let's jump right in and start beginning this discussion. Solving equations with powers. Now there are times when you'll need to be able to solve equations where the variable is being raised to a fractional exponent. The key will be to apply the product rule for exponents in a very specific way, and we'll kind of get into what that way is in exercise number 2. Before we look at this, we need to understand a fundamental difference between taking an even powered roots and odd power roots. All right, so let's jump into exercise 1 because this is kind of important as we move through the lesson. Exercise 1. Consider the equation x to the third equals 8. Consider the equations x to the third equals 8 and y to the fourth equals 625. Letter A, solve both equations for a positive value using an appropriate root. All right. Well, pause the video now and see if you can find the positive solution to each one of these equations using an appropriate root. Take a moment now to do that. All right, well, it should be rather simple. Right, if I've got x cubed is equal to 8 and I want to solve this, then I will raise both sides. I will take the cubed root of both sides. That will leave me with x equals the cubed root of 8, which I could find on my calculator, but I know that that's 2. And likewise, if I have y to the fourth equals 625, to find that solution, I will take the fourth root of both sides, and I can find that the fourth root of 625 is in fact 5. All right, so I have x equals 2 and y equals 5. Great, nothing all that unusual. And of course, you could check those by doing 2 raised to the third and getting 8, and do 5 raised to the fourth and getting 625. So what's the point? Well, let's take a look at letter B. Given the solution for x, will its opposite, its negative, also be a solution? Justify. So what I'm asking you is, will x equals negative 2 also solve that equation? Pause the video now and think about it, and then justify your yes or no answer. Well, it's kind of simple, right? So is x equals 2, right? Is x equals negative 2 a solution, right? Well, all I have to really do is take negative 2 and cube it. But that's negative 2 times negative 2 times negative 2, and that's equal to negative 8, so no, right? I'm looking for a number that when cubed gives me 8, and negative 2 doesn't. Now let's take a look at letter C. Given the solution for y, will its opposite, negative, also be a solution? Justify. All right, well, pause the video now and see if y equals negative 5 is a solution to y to the fourth equals 625. Pause the video now. Okay, well, let's take a look. So is y equal negative 5 a solution? Well, the question is negative 5 to the fourth equal 625? And if you don't want to do that by hand, right, you can take your calculator out. You just have to be careful, right? Make sure that you have parentheses around your negative 5, raise it to the fourth power, and you get 625, right? So, yeah, 625 equals 625. Yes. Now, the thing that's important about that, right, what I'm trying to get at here is that it is natural when you have x to the third equals 8 to take the cubed root of both sides. But if you take the cubed root of 8, you're only going to get 2. And y to the fourth equals 625. You take the fourth root of both sides, you're only going to get y equals 5. It's important that when you do an even root on both sides of an equation to do a solution, you are always going to get a plus or minus. So not only is 5 a solution, -5 is a solution as well. And you've seen this a lot when you've solved equations like x squared equals, I don't know, 36, right? You get x equals plus or minus the square root of 36. You get plus or minus 6, okay? But that doesn't happen when you do an odd root. So for an odd root, you just get whatever you're going to get, either a positive number or a negative number, depending on whether you're taking a cubed root of a positive or taking a cubed root of a negative. On the other hand, if you're taking a square root, a fourth root, a sixth root, an eighth root, or whatever of a positive number, because you won't be able to take an even root of a negative number, but if you take an even root of a positive number in solving an equation, you get both a positive value and a negative value. And all of that is summarized perhaps a little confusingly in this box, but let's take a look at it. Solving power equations. If n is any positive integer, a is greater than or equal to 0, and x to the n is equal to a, then x equals the nth root of a, the positive nth root of a, only if n is odd, and x equals plus minus the nth root of a if n is even. Again, it basically is just saying, if I end up taking an odd root of a number, I get only one value as a solution, and if I take an even root of a number, I get both the positive and negative root, and that's going to be important in what we do today. All right, that being said, now let's start to solve some equations that have fractional exponents. An equation with a fractional exponent. We can now consider solving equations that contain fractional powers. Keep in mind, we already did solve square root equations which involved exponents equal to 1/2. But now let's jump into one that's a little bit more challenging. Exercise number 2. Consider the equation x to the 3/2 is equal to 8. Answer the following questions. Letter A. What number multiplied by 3/2 will result in 1? Boy, I just cannot read that. What number multiplied by 3/2 will result in 1? Illustrate. So hopefully you already kind of feel comfortable with this from years and years in math. What would I have to multiply 3/2 by in order to get 1? Pause the video and think about this for a moment. Well, the answer is going to be its reciprocal, right? So the answer to this question is 2/3. And it's really simple, right? If I have 3/2 times 2/3, I could either think about it as cross-multiplying and just being left with a bunch of 1s, or I could think of it as if I do 3/2 times 2/3 and I multiply their tops and bottoms, I get 6/6, which is also equal to 1. Okay, now this is really going to be the key to solving fractional or equations that have fractional exponents. So let's take a look at letter B. Raise both sides of the equation to the number you found in A to solve it. Check your solution. Here's what I mean by that, right? If I've got x to the 3/2 is equal to 8, and I raise this side to the 2/3, and I raise this side to the 2/3, the product property of exponents says that I multiply these two together, and I'm just going to get x to the first, and then I have 8 to the 2/3. Now, I need to finish that, and I will in a moment. But I could literally take my calculator out right now, right? And I could just say, all right, well, calculator, please tell me what 8 raised to the 2/3 is. Now, I can also use roots and things like that, but 8 raised to the 2/3 is 4. Now, just thinking about our previous exercise where we were talking about even roots, odd roots, things like that, right? The root here is really a third root, right? The power is squaring, the root is the third root, and therefore I only have to worry about a single answer because we're doing an odd root. And yet, I have it now, right? X is equal to 4. So x is equal to 4. It does say check my solution. So if I wanted to do my check, I would have 4 to the 3/2 is equal to 8, right? That's the square root of 4 cubed is equal to 8. That's 2 cubed is equal to 8, and that's 8 is equal to 8. You bet. So the key to solving fractional or equations that have fractional exponents is basically isolating the variable that has the fractional exponent and then raising both sides of the equation to the reciprocal power. So if that's 3/2, we raise both sides to the 2/3, so the 3/2 and the 2/3 cancel and just give me an x to the first. Okay, and they always will, as long as I'm raising it to a power that when I multiply the two powers together, leave me with the variable raised to the first power. Now, there's sort of another way to think about this. Let's take a look at letter C. Now solve the equation by rewriting the left-hand side in terms of a power and a root. Then undo each in turn, compare with what you did in B. All right, so in other words, I can also think about this as I've got x to the 3/2 is equal to 8. Okay? And I could rewrite this thing as the square root of x to the third is equal to 8. Right? So that's one way of rewriting this equation. Now, to undo this, okay, I could then take the cubed root of both sides, and that's going to cancel, leaving me with the square root of x is equal to the cubed root of 8, which is 2. And then I could square both sides, and I could get x is equal to 4. Now think, though, about what I had to do there, right? I had to, so this is my comparing it to what I did in B, right? I had to do two operations. I had to undo the cubing by doing a cubed root, and then I had to undo the square root by doing a squaring on both sides. Now that's really kind of what I'm doing up here, right? Here, when I raise both sides to the 2/3 power, I'm both really doing a cubed root of 8, and then I'm squaring the result. So the cubed root of 8 is 2. Squared ends up giving me 4. So I'm really doing the same two steps. The key is, though, right, on my calculator, I can simply do 8 to the 2/3 and immediately get the answer 4. Here, I have to sort of go through a two-step process, but both of them work great. All right, let's do some more solving of equations that involve fractional powers. The last exercise illustrated the general method by which we can isolate a variable if it's raised to a fractional power. Since these problems involve radicals, parentheses roots, we need to consider if the root is even, in which case we're going to get two answers, or odd, and we need to watch out for extraneous roots, and we'll kind of see that come up in the last problem. Yeah, that's right, extraneous roots are back. Exercise number 3. Consider the equation 3 times x to the 2/3 plus 16 is equal to 64. Letter A. Solve the equation for all solutions. Show each step in your solution. All right, well, let's do it. Now, keep in mind, right, we can kind of think about this as order of operations yet again. I've taken x, I've raised it to the 2/3, I've multiplied by 3, and then I've added 16 and gotten 64. I want to subtract 16, divide by 3, and then undo that 2/3 power by raising both sides to the 3/2 power. So let's jump into it. I have 3x to the 2/3 plus 16 is equal to 64. So the first thing I'm going to do is subtract a 16 from both sides. That's going to give me 3x to the 2/3 is equal to 48. Then I'm going to divide both sides by 3, and I'm going to get x to the 2/3 is equal to 16. Now, that's kind of where I was in my previous problem. At this point now, what I can do is I can raise both sides to the 3/2 power. All right, and again, 2/3 times 3/2 is going to leave me with x to the first. Now, here's the key, though, right? Because this is an even root, because that's an even root, I'm going to get both a plus and a minus answer, right? And in fact, I can really interpret this as plus or minus the square root of 16 to the thirds, right? Plus or minus the square root of 16 to the third. And then, right, plus or minus square root of 16 will be plus or minus 4 to the third. 4 to the third will be 64. Negative 4 to the third will be negative 64. All right, now you might be saying, well, wait a second though, I started with an odd root. Sure, absolutely. But in solving the problem, you ended up having to take a square root of both sides, and because we take an even root, we're getting both a plus and minus answer. And actually, let's take a look at letter B. Show that each solution from A checks in the equation. So let's check them both. All right, let's actually take a look at both x equals 64 and x equals negative 64. Now the one that's not too surprising, the one that you would probably get no matter what, would be x equals 64. So I'm going to have 3 times 64 to the 2/3 plus 16 equals, maybe put a little question mark, equals 64. Great. So that's going to be 3 times the cubed root of 64 squared plus 16 equals 64. Let me extend my page a little bit more. Try to extend my page a little bit more. There it goes. The cubed root of 64 is 4. So I'll then have 3 times 4 squared plus 16 equals 64. 4 squared is 16. 3 times 16 is 48. And 48 plus 16 is 64. So we get 64 equals 64. Now, quite frankly, of course, you could do this check completely on your calculator by doing the store function, right, which we looked at before. Store 64 into the calculator, then type out the equation, see if it gives you a true or false. But I like to kind of work through all the fractional exponents. Now let's take a look at the one that would be easy to miss on this one, the x equals negative 64. Let's take a look at that. So with x equals negative 64, exactly the same procedure, right? I'm going to go with 3 times negative 64 to the 2/3 plus 16 equals 64. 3 times the cubed root of negative 64 squared plus 16 equals 64. All right, the cubed root of negative 64 is negative 4. And now, before we move on, you can probably now see why both of them work, right? Both of them are working because ultimately here, right, we square a negative 4. Here we square a positive 4. And whether we're squaring negative 4 or positive 4, we're going to get 16. So from this line on out, it's going to look identical to this, right? Negative 4 squared ends up being positive 16. Whoops. 3 times 16 is 48. And 64 is equal to 64. And that's really why both the negative and the positive work, because ultimately, right, we end up squaring the negative version as well as the positive version, and they give us the same number here. All right, now, if we had taken an odd root to solve this problem, we would have only had one answer. But because we took an even root, we end up having those two answers. Okay, let's keep working with this, make sure that we understand what's going on. Exercise number 4. Excuse me. Solve each of the following equations for all solutions. Letter A. 2 times x to the 3/2 divided by 5 is equal to 50. Okay, what I'd like you to do is play around with this problem, go through sort of your order of operations, things like that, try to get an answer or answers, right? You're going to have to make that decision on every one of these. Do I have one answer? Do I have two answers? All right, and see what you get. Pause the video now and play around with letter A. All right, so let's think about it. We have 2 times x to the 3/2 divided by 5 equals 50. So the first thing I'm going to do is multiply both sides by 5 to get rid of that 5, divide both sides by 2 to get rid of that 2, and then eventually raise everything to the 2/3 power. Okay, so let's do it. Let me rewrite the problem a little bit larger so we've got some room to work. And then I'll probably run out of space anyway. Okay, so I'm going to multiply both sides by 5 to get rid of that. It's going to give me 2 times x to the 3 halves is equal to 250. I'll divide by 2 on both sides. That's going to give me x to the 3 halves is equal to 125. I'm now going to raise both sides to the 2/3 to give me x to the first. And of course, you could take your calculator out and just figure out what 125 to the 2/3 is, right? If you wanted to do it without your calculator, then you'd want to think about the cubed root of 125 squared. Please note that it is an odd root, so we're going to get only one answer, right? Let me point that out. Odd root, one answer. Okay, so I have the cube root of 125, that's 5. I square it, and I actually make it look like a 2. And I get x is equal to 25. You only have to think about whether you're going to get one answer or 2 answers right at this stage, right? When you're finally getting x to the first, what did you do on this side? Did you do an odd root, in which case you have one answer, or like in the previous problem, did you do an even root, in which case you have 2? Okay, so let's keep going. Let's take a look at letter B. Here I have x to the 4/5 divided by 2 minus 5 is equal to 3. Okay, so again, why don't you go ahead and play around with this, see what you get, and then we'll work through it. All right, little order of operations discussion, right? I've got x raised to the 4/5 divided by 2 minus 5 is equal to 3. I'm going to add 5 to both sides. I'm going to multiply both sides by 2, and then I'm going to raise both sides to the 5/4 power. Here we go. Let me again rewrite it a little bit larger. X to the 4/5 divided by 2 minus 5 is equal to 3. Add 5 to both sides. That's going to give me x to the 4/5 divided by 2 is equal to 8. Let's multiply by 2 on both sides. That's going to give me x to the 4/5 is equal to 16. Let me raise both sides to the 5/4. Now here we go, right? We've got an even root. So that's going to be 2 answers. And in fact, right, we'll get x to the first is equal to, let's think about this, plus or minus the 4th root of 16 all to the 5th. The 4th root of 16 is 2, so I have plus or minus 2 raised to the 5th. 2 raised to the 5th is 32. Negative 2 to the 5th is negative 32. So I will have x equals plus or minus 32. And again, we're getting 2 answers because we're doing an even root right at this moment. All right, let's look at one last one. Here we go. Beware of extraneous roots. Because fractional exponents have radicals in them, extraneous roots can easily arise in these problems. We will look at a very simple example. Very, very simple example, because extraneous roots don't come up a ton in these problems, but they can arise in very subtle ways. Exercise number 5. Consider the equation x to the 3 halves is equal to negative 8. Find the value of x that seems to solve this equation using techniques from this lesson. Okay, great. Well, there's not much you have to do, so pause the video right now and solve this doing just what we did. All right, well, I don't have to do any kind of order of operations. I've already got the x to the fractional power isolated. All I have to do, let me write down my x to the 3 halves is equal to negative 8. Let me raise both sides to the 2/3. All right, we have an odd root, so we have an odd root, which means, if anything, we have at most one answer. Okay, and in fact, right, that would be the cubed root of negative 8, quantity squared. The cubed root of negative 8 is negative 2, and negative 2 squared is 4. And again, if you took out your calculator and you put in negative 8 to the 2/3, you would get 4. All right, so there's no hocus or pocus going on here. But now let's take a look at letter B. Show that your proposed solution in A is not actually a solution to this equation. All right, so let's take a look, right? And by the way, we could definitely just do this straight up with our calculator, right? So, we've talked about how to check a solution on a calculator. Interestingly enough, right, 4 is the thing I actually want. But if I did 4 and I stored it in x, right? Whoops, sorry about that, calculator. And I stored it in x. And then I said, okay, calculator, well, tell me, is x raised to the 3/2 all the way out equal to -8? And notice it tells me it's false. So right away I'm thinking, okay, that's not a correct solution. But let's take a look at why kind of with a hand check here. Right? So let's take a look. So we've gotten 4. So the question is 4 to the 3/2 equal to -8? Well, that would be the square root of 4 cubed equaling to -8, and that would be 2 cubed equals -8, and that would be 8 equals -8? And that is absolutely no. Right? It's false. Okay, so we've done something that is completely correct here, right? I've got x to the 3/2 is equal to -8, and yet when I raise both sides to the 2/3 power to get rid of the 3/2 power, I get an answer of +4, and yet +4 isn't correct. Now, before we kind of talk about odd roots and all of that, right, let me just say something very specific. If I have a positive number raised to any power, I don't care what it is, a positive number raised to any real number power will never give you a negative result. Let me say that again. A positive number raised to any power, any real number power, will never leave you with a negative. So immediately I know that 4 can't be correct because there's no way to raise 4 to any power and get -8. So, little word of warning, right? When taking odd roots of negative numbers, it's good to check to see if your solutions are not extraneous. Now, why do I say taking odd roots of negative numbers? Well, if in the process of solving an equation that has fractional powers, if you were to take an even root of a negative number, your calculator would just bail on you. Or if you were doing it by hand and you were like, oh, let me take the square root of -16, you should immediately be like, well, that's not even possible, right? Because I can't take an even root of a negative number. So the only way an extraneous answer is even going to occur is if you end up taking an odd root of a negative number. Now, in that case, you could still get a valid solution depending on how the equation is structured. But it may not be correct. So you have to really check if you ever find yourself taking odd roots of negative numbers. Again, even roots of negative numbers, no worry there because you simply either your calculator or if you're doing it by hand, you'll know, well, I can't take an even root of a negative number. But an odd root, you can, and it can leave you with an extraneous solution. So let's wrap this up. There's a lot of kind of ancillary stuff in this lesson, including the extraneous roots, which we just talked about. Also things like both having the positive and negative root. Ultimately, the most important thing to take out of this is if you're trying to solve an equation where a variable is being raised to a fractional power, you want to isolate that variable raised to a fractional power by, undoing order of operations. And then you want to raise both sides of the equation to the reciprocal of whatever that power is. So if I eventually have x to the 2/5 is equal to, 16, then I want to raise both sides to the 5/2 to get rid of the 2/5 power. And that's a really kind of great use of that product property of exponents, because if I have x raised to some fractional power and then I raise it to the reciprocal, when I multiply those two fractions together, I will simply get x to the first or y to the first or what have you. So it's an important technique, and I hope that it really kind of makes sense in terms of everything that we've done with sort of both exponents, roots, and the product power of exponents. For now, I just want to thank you for joining me for another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.